The lesson outcome for this video is I can review adding, subtracting, and multiplying polynomials. So for this unit, we are going to use these three operations, and this video just reviews each of those three topics. First of all, this is a 4-term polynomial plus another 4-term polynomial, and I want to remind you that when you add them, all we need to do is combine like terms. In fact, if you wanted to rewrite the addition of these two polynomials, you could do so by just getting rid of the parentheses. So 3x to the third plus 2x squared minus 5x plus 7 plus everything in the next set of parentheses plus negative x to the third minus x squared plus 8x plus 1. At this point, all we need to do is combine anything that has like terms, like variable part. Remember, like terms are all about the variable part. So x to the third and x to the second cannot be combined because their variable parts are different. However, this x to the third term can be combined with this x to the third term because they have the same variable part. So if we have 3x to the third here, and then we have plus a negative x to the third here, altogether, if we think of this as a negative 1 right here, we have 3 plus negative 1, which is 2. So we have 2x to the third. Next, we can look at the positive 2x squared. We have another x squared term. It is right here, and that is again a negative 1x squared. So we have positive 2 and negative 1, which when we add them gives us positive 1x squared. You don't need to put the 1 right here, but you can if you'd like. All right, so next we have negative 5x. Do we have any other terms with an x variable part? Yes, we do. It's over here, positive 8x. So negative 5 plus 8 is 3. So we have plus 3x. And then lastly, we have positive 7 right here and a positive 1. Those are both constants and they can be combined, and when you add 7 and 1 it is 8. So our answer for this addition of polynomials problem is 2x to the third plus 1x squared plus 3x plus 8. The second operation we will practice in this video is subtracting two polynomials. So we have 2x to the third minus 5x plus 3, and we need to subtract the entire second polynomial of 4x to the third minus 2x squared plus 3x minus 4. This is the one that you need to be careful with because this subtraction symbol means we need to subtract every one of these parts. So that's when we talk about distributing that negative or negative 1 to every term. So I'm going to rewrite again. So I will write, I will keep my first polynomial as it is, so 2x to the third minus 5x plus 3. Nothing changes in that first polynomial. But now I need to make sure to give this negative sign to every single term in the parentheses. So we have to be careful when we do that. So we've got minus 4x to the third. So minus 4x to the third. Typically that's not one that people do wrong. It's the next three terms, because then people want to just write minus 2x squared, but that's not true. We have to do minus negative 2x squared. So what's a minus a negative 2x squared? Well, minus a negative becomes plus. So we have to change that sign to plus 2x squared. And then we have to do minus a positive 3x, so minus 3x. And then we have to do minus negative 4. Minus a negative 4 means we're going to add 4 at the end. At this point, the problem is just like we had on the previous screen. We need to combine like terms that have the same variable part. So we've got a 2x to the third right here and a negative 4x to the third right here. So we've got positive 2 minus 4, which would be negative 2. And again, we leave the x to the third as it is. That's the term, or the variable part. All right, so next we have negative 5x. And again, I just go from left to right when I'm combining. And what you have to be careful for here is that in the first term, or sorry, the first polynomial in parentheses, we didn't have an x squared term, but in the second set of parentheses we did. So right now I'm skipping over that for right now, and we'll talk about what happens with it later. So we do have another term with an x for a variable part, and that's negative 3x. So we have negative 5x's and negative 3x's, and together that's negative 8x. Okay. Then we have positive 3 right here. That is a constant, no variable part. And we have the constant over here, 4. So together that's 7. So plus 7. Now be careful not to miss the last term that we have not yet used, and that's right here. We haven't written that down yet. So we need plus 2x squared. So plus 2x squared. Now technically this is a true simplified version of our original problem, but we do want to rewrite that in standard form. And remember what that means is we need x to the third. If that's our largest exponent on a variable, that goes first. And if you look, then we have an x squared. That term should go second, then an x term, and then our constant should go last. So if we rewrite this, we should have negative 2x to the third plus 2x squared minus 8x and plus 7. This is the best answer for this subtraction of polynomials. And the last type of example I'll do in this review video is multiplication of polynomials. Remember, when there's no symbol in between the parentheses here, that means multiplication. There are a couple different ways I've taught multiplying polynomials. One way is just to make sure every one of these terms gets multiplied by every one of these terms. But my favorite method for this is using an array. So I'm going to make an array that has 3 rows and 2 columns because there's 3 terms and there's 2 terms. So 3 rows and 2 columns probably would look something like this. I'm going to write my terms for my first polynomial over here. So 4x squared, positive 3x, and negative 2. And up in the top, 5x squared and plus x. Now again, we're going to multiply this by this and write it here. We're going to multiply this by this and write it here, and so on and so forth to fill in our array. So our first one, 4 times 5 is 20, and x squared means x times x times x times x, which is x to the 4th. So we have 20x to the 4th. Then I'm going to multiply this by this, and again, it doesn't matter what order. If you wanted to do the 3x times the 5x squared next and put it here, you can. But I'm going to do 4x squared again times x. So we have 4, and we had x squared, which is x, times x, which is x to the 3rd. Next, 3x times 5x squared. Well, 3 times 5 is 15. And x times x squared is x times x times x, which is x to the 3rd. 3x times x is going to be 3x squared, because x times x is x squared. Next, we have negative 2 times 5x squared, so negative 2 times 5 is negative 10. And then we still have the x squared part here. And then lastly, we have negative 2 times x, and that's negative 2x. Now, we're not finished until we write this as a polynomial. So the next thing we're going to do is we're going to write it as a polynomial, and we can combine like terms after we write all those 6, because again we have 6 terms here, 1, 2, 3, 4, 5, 6. If you wanted to write all 6 terms out, you could, and then combine like terms. That's totally fine. Or we can combine like terms before we write it out. So what I mean by that is, I notice right here I have an x to the 3rd variable part, and I have an x to the 3rd variable part here. So I can combine those. They are like terms. I also notice I have an x squared term right here. I'm going to make sure to get that negative sign in front of the 10, and I have an x squared term right here. So again, I'm going to combine those when I rewrite my polynomial answer. So my x to the fourth and my x term don't have any other like parts, so we're not going to circle those. And now we can write our final polynomial. So we're going to write 20x to the fourth, because that's from right here. Then we have these two that are circled in yellow. They're both x to the third terms, so we have 15 of them and 4 of them. Together that's 19. So 19x to the third. Then we have negative 10x squared and positive 3x squared. So negative 10 and 3 is negative 7, and we'll leave the x squared. So, whoops, let's take that away. It is negative 7x squared. And then lastly, we have negative 2x. And that got a little messy there. This is our answer. It is written in standard form. I have x to the fourth first, x to the third second, x squared, and then my x term. Notice there is no constant in our solution, and that's fine.